Let's take a look now at this example. So what do you see? You see a beam, a horizontal beam, tied here with a little hinge towards a wall. There is a string that holds the beam horizontally, and we have some sort of a weight, a package pointing at the end of the beam. So what kind of forces does it act on this situation? And remember that it's in equilibrium. Okay, let me make it a little bigger. Okay. Maybe it was a little bit too big. Is there 150% maybe? No, but I can choose from here. Image size. There we go. That should be fit in a screen. Okay, so I will say that the first force that you should think about it and to start with is obviously the force of gravity, right? So who has a mass here? Obviously the beam, the whole horizontal beam, and right here in the middle, where is the center of mass, we can draw the force of gravity. So this is force of gravity. Let's call it 1 because it's referring to the beam. But also, this object, the weight or the package, whatever is here, it has also a weight. It's attracted by the earth. So we're going to draw the corresponding force of gravity, and let's call it 2 because we are two separate different objects. Now, we see the string. At this point, you should realize that if there is a string, let's say hypothetically, I'm going to cut the string here, what will happen with the beam? It's going to rotate and fall down, right, south. Therefore, there has to be a force in the string that will hold this beam horizontally. So that's the force of tension. Okay, or we can label it, to use the capital T, force of tension. Now, what's going on here at the hinge, right? Well, there is the hinge, the beam, the horizontal beam makes contact with the wall, so there has to be a force here that acting towards it, right? Now, what is the direction of the force? As you remember when we talk in class, when we have a hinge, there are two actually forces. There is a force in a vertical direction, right? Let's call that F vertical. And there is a force this way in a horizontal direction. Let's call that FH. Those two forces, excuse me, excuse me. Those two forces together are the ones who provide the normal force between the beam and the wall. Right? So we have 1, 2, 3, 4, 5 different forces acting on the same on this situation. So if we have to draw the free body diagram, let me pick probably this color. All of them in one spot. This is what they're going to look like. We have the force of gravity 1. We have the force of gravity 2. And we have the vertical force. Right? Let's make this a little bigger. And we have the horizontal force FH. And we have the force of tension. The key word here, equilibrium, right, it suggests that all these forces somehow they have to cancel each other out. Therefore, that if we split those forces in a horizontal and in a vertical direction, in a vertical and horizontal direction, the sum of all these forces have to be equal to 0, right? So we can write that the F net equal to 0, right? So the next step is to find the components for each force that is not horizontal or vertical, which in this case is just the force of tension. And then we can write that the force of tension in y direction has to be equal with the sum of the vertical force plus the force of gravity 1 plus the force of gravity 2. There is no net force in a vertical direction. And the force of tension in the x direction, horizontal, has to be equal with the horizontal force from the hinge. And from this point is just math, right? So the free body diagram, where you have to understand is how these forces appear. And I think I have here, yeah. That's the diagram.